Welcome students to another video lecture with Mr. Connect. What we are about to cover is adding and subtracting integers. Remember, I've started to try and make us focus on the fact that there are only rules in mathematics for addition and multiplication. So in this lesson, we're going to learn how to add, and then we're going to learn how to take all subtraction problems and turn them into addition problems first. Go ahead and pause here and copy down what you see. All right, welcome back. So our focus for this is when adding, how do you tell whether the sum is positive, negative, or zero? And how do we change subtraction into an addition expression to simplify? So those are our two focuses throughout this lesson. So the first thing we're going to focus on is adding with same signs. And if you did not write this heading, adding with the same signs, you're going to get really frustrated quickly when there are 3 different instructional steps laid out in this note and you don't know which one to use. So please make sure the heading is there. It does matter. The steps do need to be here, and these are models for 2a and 2b. So if it's same signs, so anytime you add integers with the same sign, you add their absolute values together. And if both integers were positive, the sum is still what? Yeah, positive. So let's go over model 2a over here. They're both positive, 21 and 4. We add them together, their absolute values, we end up with 25. I know, so hard. Okay. If they're same signs, both being negative, you will both add their absolute values, and the sum of them will be negative. So the absolute value of negative 7 is 7, and the absolute value of negative 10 is 10. So 10 plus 7 gets us 17. And then we need to keep that negative on there since they were both negative to begin with. So our answer is negative 17. Again, it's going to be really important as we go through these problems and these examples that you're reading these steps every single time. The most common mistakes for students is they apply their rules for multiplying integers to when they're adding integers. Best way to clarify that is to make sure you read all the steps and have them cemented in your brain. So I'm going to slide one more slide ahead. Notice I drew the squiggly line above these steps, and then we're going to start writing the heading, adding with different signs, because that is our next step process. So go ahead and pause here and copy down what you see. Excellent. Welcome back. Okay, so now we're going to figure out the rules of adding 2 integers whenever there are different signs. And this reflection question is important here on the left side here. Do these rules apply to subtraction? No, they don't. You have to turn subtraction problems into addition problems before you can use any of these rules. That's why they all start with the word adding. Okay, so if 2 integers have different signs, we subtract their absolute values. Remember, that's their distance from 0. And then we figure out which sign to keep by keeping the sign with a larger absolute value. It's all about that larger distance from 0. So negative 8 plus 3, example 1. They are different signs, so we're going to have to do 8 minus 3. Their absolute values, you get 5. The larger absolute value of these two was negative, so the answer is negative 5. All right, let's try example 2. Oh, they're different signs, so we're going to have to subtract their absolute values. We get 3. And the larger absolute value is 7, not negative 4, so our answer is a positive 3. Remember, if you have any questions on these 2-step processes I just guided you through, please write them down next to these steps in the question column. So I'm going to show a couple problems on the next page, and I'd like you to leave space for us to perform these problems, so don't write it as paragraph form. Don't make it look like a book. It should have spacing so that we can get some work below each of them. So there are going to be 5 more examples. I'm going to say pause here and copy what you see. Okay, welcome back. So these are examples, not really guided examples. But the key I want you to realize is when you go through them, I expect you to read the notes that go with them. So I'm going to model what I want to see happen on the next 4 problems with problem 3. So problem 3, we have negative 3 and we have a negative 15. Same signs or different signs? Yeah, you're right. They're both negative, so same signs. I go back to my directions for same signs. I read what to do. It says add their absolute values. We knew they were both negative, so I went to 2b right away, and I notice I'm going to keep my sum to be negative. What I'm modeling here is I expect you to read those instructions, each one of these examples. So 15 plus 3, we're adding their absolute values. It's 18, and then we keep the negative because they were both negative to begin with. The answer is negative 18 for example 3. So again, as I let you go free on these next 4 models, please make sure to read the steps as you go each time. So pause my video lecture so you can work through these problems first, and then I will show you the work after the pause. So pause here, finish all 4 problems, and then I'll show you the work. Okay, welcome back. So problem 4, we got 54 plus 21, both positives. So we use the adding with same sign directions. We get 75. Both were positive, so the answer is staying positive. Moving on to number 5. Negative 8 plus 10. They are different signs. Since they're different signs, we have to subtract their absolute values. And we keep the sign of the larger absolute value. 10 is farther from 0, so our 2 is going to remain positive. Number 6, 23 and negative 56. These are different signs. Therefore, we are going to subtract the absolute values. The number with the larger absolute value is negative 56. So I'm going to place that there. And our answer is negative 33. So in the problem 4, the challenge in problem 4 is realizing that it is talking about negative and positive numbers with these words below sea level, rose 194 feet. So we're going to translate this from left to right. So a blue whale was at a depth of 275 below sea level. In any geography, they always consider sea level to be 0. 0 feet high. Sea level is 0 feet high. So anytime you go below 0 feet or sea level, you should have a negative number. And anytime you go above sea level, you should have a positive number. A perfect example of that is Lake Tahoe is 6,282 feet above sea level. And that is an average number. It does actually fluctuate. So translating this problem from left to right, we have negative 275 because it's below sea level. We rose. When you rise, is that adding or subtracting? Yeah, rose is adding, and we added 194. So they're different signs. We need to do some subtraction on the side. We get 81. The larger absolute value is negative 275, so our answer should have a negative on it, and we get negative 81. Oh, that was a horrible way to state that answer, actually. I should have written negative 81 feet, or we could actually write the sentence 81 feet below sea level. Okay, so moving on here. I'm going to show you the next 2 slides. Please make sure to leave space. Notice I just drew a squiggly line. What we're about to model here is how to use a number line, and I'm actually going to show this example in class. And then we have the additive inverse property as well. So segment these 2 pieces. I'm actually going to show guided example 8 within class. This is how Common Core wants us to teach number addition, but we're going to discuss in class how it's extremely limited, and we should just learn the adding rules instead. Okay, so pause here and copy these 2 slides down. Okay, welcome back. So like I said, I'm going to talk about using a number line this whole section in class. So we'll model that in class. What we're going to go over right now is that additive inverse. So what this is teaching you is any 2 numbers that are opposites and added together equal 0. So the sum of any number and its additive inverse. Oh wait, I said opposites. What is a synonym for additive inverse then? Yeah, if you said opposite, you're right. So anytime you add 2 numbers together, you get the number 0. So the additive inverse of 33 is negative 33. The additive inverse of A is negative A. And really, this property that I'm teaching here doesn't make sense until you apply it into our future problems. So that's why I have how it's used in our future. I'm actually not going to solve this equation out. I'm just going to show how we use the additive inverse. So how we're going to get variables by themselves is we're going to have to use additive inverses or multiplicative inverses to get numbers and variables from the left over to the right of an equal sign, or from the right of an equal sign over to the left. So in this case, we're trying to get rid of positive 6. We're trying to turn positive 6 into a 0. So we place its additive inverse below it. So what's the additive inverse, the opposite, of positive 6? Yeah, it's negative 6. And we're going to learn later that we have to be fair, and when we do something to the left, we also do it to the right. And therefore, the next line equals 5x equal to 4. So we were able to use our additive inverse here to help get this 5x by itself. So that's how we use the additive inverse. So going to keep on moving forward here. We have 2 more slides ahead of us. This is going to be focused on the subtraction part of our lesson. So can everyone please pause here? Actually, let me get example 9 in here first. We're going to have 5 minus negative 16 as our example there. So go ahead and pause here and copy down what you see. Okay, welcome back. I'm only going to go through example 9 here. We're going to do 10, 11, and 12 in class. One more time, I'm going to do 10, 11, and 12 in class. But example 9, I'm going to show the steps for changing subtraction into addition so we can use those addition rules to combine the numbers. So when we change them or behind, I've always had problems with students with this behind word. Just so you realize, behind, a synonym for it in our math would be after. And remember, we read stuff from left to right. So the number behind our subtraction sign in this example 9 is a negative 16. So we're changing it to its additive inverse, which is just a synonym for its opposite. Then we change the subtraction sign into addition. And we're going to bring that 5 straight down. And now that we've changed it into an adding problem, we can use our adding rules. These are same signs. We add their absolute values. We end up with a 21. They're both positive, so it stays positive 21. Again, if you have any questions throughout these lessons, get the questions in these question columns. We're going to do 10, 11, and 12 in class. Thank you so much, students. I know this got a little long. I tried to keep it at that under 11-minute mark. It's getting up to 13 here. I may have to cut this down even more next year. Thank you so much for your time today. I'll see you in class.